If you have not yet, go ahead and turn in your notes to 2.5. Today we're going to be talking about dividing rational numbers. Now, this past week we've talked a little bit about reciprocals. Everybody say reciprocal. If you remember, a reciprocal is just when you flip a fraction, okay? So instead of 3/4, what would the reciprocal be? 4/3. To the right, I want you guys to go ahead and write that with your pencil and box it in. For this section, we're going to be doing kind of more of that same practice, write the reciprocal of the number. So first up, Talila, what would 3/5 be as a reciprocal? 5/3 is correct. Problem B is not a fraction, but I need it to be a fraction. What number can I put underneath it?
1.
A 1. So go ahead and put it over 1. Noah, what would this reciprocal be? 1/2, which is 1/2. Reese, can you tell me what to do for problem C? Very good. We've got 10/7. Now the final one looks a little different because it's a mixed number. I have to turn that mixed number into looking like a regular fraction, which would be an improper fraction. Just the boys, what would this be as an improper fraction? 9/2. And just the girls, what would the reciprocal of 9/2 be?
2/9.
2/9. Do you guys feel like you understand reciprocals? Okay, all a reciprocal is flipping a fraction. So it's got to be a fraction in order to have a reciprocal. Now I want to talk to you about KFC. How many of you have ever had KFC chicken before? Okay, Kentucky Fried Chicken. All right, how many of you have other chicken places that you like better than KFC? What's another chicken place you might like? Popeyes, what else? Chick-fil-A. I agree, Chick-fil-A is awesome. Okay, those are the main ones. But today we are going to use KFC to help us with something. So I want you to pull out your red pen and go ahead and write down this very first part about KFC. Repeat after me. KFC.
KFC.
Keep, flip, change.
Keep, flip, change.
So we're going to use this model anytime that we have to divide a fraction because, as you've just written down here, read me those first 4 words with the star next to it. What's it say?
You can divide fractions.
Interesting. So this means you are never allowed to divide fractions. Everyone say, you're never allowed to divide a fraction.
Never allowed to divide a fraction.
Instead, I've told you what you have to do. You have to multiply by the reciprocal, which means you have to flip the fraction. So let me explain to you with this down here. 1/2 divided by 3/4. Keep the first one, which is 1/2. Write this down in your notes. Flip the second one. So instead of 3/4, what will it be? 4/3. And change the operation or change the sign. Do you guys know what the opposite of a divide sign is? So we are going to change it to a multiply. Now that oh good, you remember this from before. Now that I have this, I am allowed to cross reduce. Let me explain something to you. If you ever have a situation like this where you're dividing, you're not allowed to cross reduce. When you're adding and subtracting fractions, you're not allowed to cross reduce. The only time you can cross reduce is when you're multiplying. So can I cross reduce anything with 1/2 and 4/3?
2.
Okay, the 2 and the 4. Let's go ahead and cancel them out. What do the 2 and 4 become?
1 and 2.
A 1 and a 2. Now I'm allowed to multiply the numerators together and then the denominators. When I do that, what do I get? 2/3. So the correct answer is 2/3. That's how KFC works. And I'm glad to see that some of you guys remember learning that before this year. So we're going to do a few problems practicing with KFC. Remember, KFC is only used when we divide fractions. All right, let's do the first one. Repeat after me. KFC.
KFC.
Keep, flip, change.
Keep, flip, change.
So for the first one, Matthew, help me with it. I'm going to keep the first one, which is 5/9 or 5/9. I'm going to flip the second one. So what will it flip to? 3/2. And I'm going to change the operation to multiply. Very good. Matthew, can I cross reduce anything? The 9 and the 3, what did they become? 1 and 3. Now I want you to multiply across for me, and what do you get? You do get 5/6. As I look at this, they're only positives, so my answer is still going to be a positive fraction. 5/6 is correct. Let's move on to problem B. If I could have Braden keep the first one, which is 6/5, flip the second one, okay, but keep the negative with it, so it'll be -3/4, and change what? Very good. We're changing that operation to multiplication. Is there anything I can cross reduce, Braden?
3 and 6.
Very good. Oh, not 3 and 6. Listen, when you cross reduce, it's got to be the ones that are across from each other diagonally, not side to side. So the 4 and 6 I can cross reduce. What can go into a 4 that also goes into a 6?
2.
A 2. Braden, how many times does 2 go into a 6?
3 times.
And how many into the 4? Very good. Now you can multiply across. Tell me what you get as you multiply it. All right, very good, 9/10. Now if I see this and I look at my original problem, I have one negative fraction. So should the answer be positive or negative? It should be negative because remember, whenever you have an odd number of negative signs, your answer will always be negative. Any questions about how to use the KFC method with dividing fractions? All right, we're going to go on to the next part. Now we're going to be dividing decimals. When you have decimals, we no longer need to use KFC because that's flipping fractions, okay, for KFC. Now I'm just working on using some decimals here. So the first thing says -8.4 divided by -3.6. Is my final answer going to be positive or negative?
Positive.
It will be positive because there's 2. So right now I'm just going to work it as if there's no negative signs there. I've got an 8.4. When it says divide, you are going to be dividing it on top. Put that little division sign on top of it, and then the 3.6 goes to the left. Now here's an interesting fact that you probably knew at one time but maybe forgot. You are not allowed to divide anything with a decimal. So I've got to move that decimal. Please take your red pen, and I want you to move that decimal over here to the right, just one spot. If I move that decimal to the right one spot, guess what I have to do to the other one? Also move it over there one time. Now, put your red pen down, and I want you to work with me. We are not going to work on this section right here. I am going to rewrite it without the scoops, okay? So now we're still trying to work underneath this problem, but to the right, instead of 8.4, what do I have?
36.
I have 84, and instead of 3.6, what do I have? 36. Once again, I don't want you working with this one where we've written the scoops. Go ahead and rewrite it for me so that it's easier to read your work, okay? And we're doing this just with our pencil. I'm going to put a decimal point at the end, and how many zeros do we typically put?
3.
3. Bring that decimal point up before you start the division. Now, when you have a problem like this, you're going to try to think of this and round it to a nice rounded number. What would that round up to?
2. 4.
It rounds up to a 40, okay? So instead of thinking 36, now I'm going to think 40. Count by 40s till you get to 84. And what'd you guys say you got?
80.
Okay, and 80, which is how many times? 2 times. So let's go ahead and put the 2 up on top. Talila, will you multiply that out for us? 2 times 6 is? So what is 2 times 6? Okay, very good. That's a 12. And then 2 times 3 is 6 plus 1 is 7. Talila, when you subtract, what do you get?
12.
Very good. Is that 12 smaller than the 36?
Yes.
Yes, that means that your 2 right there was a good number, okay? So now, drop down a 0. Remember, we rounded this to about a 40. How many times would a 40 go into 120? Okay, because when we count by 40s, 40, 80, 120, it's about 3. 3 times 6 is 18. Put that 1 on top again. 3 times 3 is 9, plus 1 is 10. Now we're going to subtract it. What do you get when you subtract it? Okay, we get a 12. Now I'm going to bring down a what? 0. Once again, think of the 36 like a 40. 40, 80, 120. About how many times, guys? 3. Do you guys sense any kind of a pattern here?
Yes, it's repeating.
Yes, it's repeating. So Talila, if you would, what do you think my final answer would be? Very good. So instead of writing 2.333333 and going on forever, you can do 2.3 with a line on top of the 3. And help me out. Would this be a positive or a negative?
Positive.
It is going to be a positive. And then go ahead and box that answer in. So Ava, negative 2.4 divided by 3.2. Very good. And am I allowed to divide with decimals? No. So what should I do to the decimal points? Bring it to the side. So I want you guys to use your red pens once again to show me this work. That just says, I understand I'm not supposed to use a decimal when I divide. And then if I do that to one, I've got to do it to the other. Now, I want you to rewrite it. Remember, please do not do the work right here on this one. That's just showing me you've moved those decimal points over. Now, off to the side, we're going to do 24 divided by 32. Put your decimal point and add 3 zeros. Ava, we're going to round that 32. What would you round it to? A 30. Very good. Okay, now can a 30 go into a 24? No. So let's try if that 30 can go into 240. All right, so her guess is a 6. 6 times 2 is 12. Carry the 1. 6 times 3 is 18. Plus 1 is 19. But when I subtract, I see that the answer is 48. Is 48 smaller than 32? No, it's not. So guess what that means? My 6 was not big enough. So we got to erase that and try again. Let's try with a 7 and see if that works better. 7 times 2? 14. 4 on bottom, 1 on top. 7 times 3? 21 plus that 1? 22. Now let's try this out. Instead we get 16. Is 16 smaller than that 32?
Yes.
Yes, it is. So that's better. That means the 7 is the number we really wanted. Keep going, Ava. Bring the 0 down. All right, now count by 30s. Remember, we rounded this number to be about a 30 because that's easier to count than counting by 32s. And what do you get when you get to 160? All right, let's try 5. 5 times 2? 0 on bottom, 1 on top. 5 times 3? Plus 1. And when you subtract it, you get 0. This is when I always feel very, very happy because it worked out evenly. Yay! All right, now let's go back to our original problem right here. Ava, should my answer come out as a negative or a positive? It is going to be a negative because there's only one negative sign. So remember, please don't box it up here on top of all that work. Just come off to the side, negative 0.75, and then box it in. Here we're going to evaluate the expression when x equals 3/5 and y equals 10. Repeat after me. Plug it in, plug it in.
Plug it in, plug it in.
We want to get rid of these letters, okay? Math should be numbers, not letters. So instead of a y, what am I plugging in? A 10. Bring down your divide. Instead of an x, what am I plugging in? 3/5. Whenever I'm doing a problem like this, I want them to look similar. So either I want both of them to be a whole number or both of them to be a fraction. What's the easiest thing to do?
Fraction.
Let's turn the 10 into a fraction. What do I do?
Put a 1 under it.
Put a 1 underneath it. Am I allowed to divide fractions?
No.
Am I allowed to do this? Cross this out and cross that out? No, you are not allowed to cross reduce anything unless you're multiplying. Repeat after me. KFC? Jalen, I want you to keep the first one, which says 10 over 1 is the first one. Flip the second one. What would that say? 5/3, and change the operation to multiply. Is there anything I can cross reduce? There is not. So I just want you to multiply across the top and then the bottom, and what do you get? 50 over 3. Am I finished?
No, you have to reduce.
Okay, that's improper. Remember, any time that the number on top is bigger than the number on bottom, that's bad. It's improper, so we've got to fix it. Do you think I want my final answer to be a decimal or a fraction?
Fraction.
A fraction. Notice, I have started off the problem in my instructions with fractions, which means your answer needs to come back to me as a fraction or a mixed number. So we're going to go ahead, 50 divided by 3. Jalen, how many times does 3 go into 5? Okay, so the 1 goes on top. 1 times 3 is 3. How many times does 3 go into 20? 6 times. Nope, 6. 6 times 3 is 18. And now give that to me as a mixed number. What would that be as a mixed number? No, start with your whole number. Okay, this is my whole number, 16. This 2 down here becomes the numerator, and this right here becomes the denominator. So what's the answer? 16 and 2/3 is the final answer. Any questions on that problem? All right, I want you guys to do the next one on your own, problem B. First things first, plug in the X, and then see what you get. Let's see how you did. First things first, make sure you've plugged in the correct thing. It was 3/5. Flip the second one. Some people forgot to flip, and then change the operation. Now here's the deal. Some people chose to cross-reduce. Some people didn't, but you can still get the same answer even if you don't cross-reduce. This equals 3/2. But I'm not allowed to do that because the top number is bigger than the bottom. That's improper. So if you know how to do it in your head, excellent. If you don't, you can always work it off to the side. What's the correct answer? 1 1/2. 2 thumbs up if you were able to get that. All right, so this is a word you probably haven't seen in a long time. It says to find the mean of the data set. A long time ago, you learned things like mean, median, and mode. Is there anyone who remembers what the mean means? Have you guys ever heard the word average?
Yeah.
Okay, that just means the average. You've got to add up all the numbers and then divide by the number of numbers you have in your data set there. So let's go ahead and add these things up. So you're just going to take your data set and put it over here off to the side. Let's add these things together. 4 plus 6 plus 1 plus 2
13.
plus 6
19.
plus 2
21.
plus 5
26.
plus 2,
28.
28. 8 on bottom, 2 on top. Add the rest of those in 3, 2, 1. What do you get?
108.
108. No, it did not say please add everything for me. Instead, it asked us for the mean. So now what do I need to do with that 108? Divide it by how many numbers were in my data set. How many numbers are there? 9 of them. What's 108 divided by 9? 12. So the average of all those numbers was 12. I want you guys to do problem B on your own. All right, Reese, I think that was you that said you got it. When you added the numbers together, Reese, what'd you get? 30 is correct. Divide it by the number in the data set, which was 6. And what's your answer? And you get 5. That is correct. Okay, now remember, whenever you're finding the mean, you want it to be in between the smallest number and the biggest number. Was 5 in between a 1 and a 10? Yes, so the average of all of those numbers right there was 5. So this is our last problem today. It's a modeling real life problem. A restaurant launches a mobile app that allows customers to rate their food on a scale from -5 to 5. If somebody did not like their food at all, what would they rate it as? -5. If they loved it a ton, what would it be? +5, okay? So far, the customers have given some lasagna scores. I want you to read right there what lasagna scores they've given. Okay, so there's quite a few different ones. Looks like someone gave a 0, some gave some negatives, and some gave some positives. The question is now asking us, should the restaurant consider changing the recipe? So what we're going to do is we're going to actually find the average. And average means it's kind of helping you to understand about what everyone's main idea comes to, okay, kind of what they're thinking. So the first thing I want us to do is we're going to go ahead and underline anything that was a positive score. What's the first positive score you see there? 2.25. What's the next positive? 0, well, 0 kind of cancels out because, I mean, we could say it, but it's not really positive or negative. 1.75, and what else? 3.5. Now, do you guys see any negatives there?
Yes.
Let's circle the negatives. What's the first one?
Negative 3.5.
What else?
Negative 4.5. And negative 1. And negative 2.5.
All right. What I want us to do today is we're going to add up all the positives, and then we're going to add up all the negatives. And then we'll combine the scores, okay? Because remember, same sign, add and keep. So let's stick with our positives first. First one was 2.25. And as you remember, a 0 basically means nothing. So I'm not really going to add it into anything because it won't change it. Then I've got 1.75, 3.5. Do I need to line up decimal points or no?
No.
Yes. Anytime you're adding, you always do. So actually, let's stick a placeholder. What's the placeholder?
0.
Good job. Add that up on your own. When you guys added that up, what'd you get?
7.50.
7.50. Okay, so that's the positive scores that they got. Let's now add up the negatives. What's the first negative one there?
Negative 3.5.
3.5. What's the next negative?
Negative 4.5.
Next negative?
Negative 1.
Where's the decimal point on negative 1?
Behind.
Behind it. So let's just do 1.0 because that means the same thing as a 1. And the last one?
Negative 2.5.
Very good. Let's add up the negatives because remember, same sign, add and keep. Our answer is going to be negative, but let's add all the numbers and keep the sign. What do you get?
11.5. Negative 11.5.
Very good. That's going to be an 11.5, but it is a negative because I just added up all those negative numbers. Now I want to combine that score. So we're going to go ahead and take our 7.5, which was a positive, and subtract 11.5. Same sign or different sign?
Different sign.
So I'm going to subtract and take. Remember, when you're subtracting, you always put the biggest number on top. What do you get when you subtract them?
4.0.
4.0, which just means a 4, and take the sign of the larger number.
Negative.
Negative. So here's the deal. As we just added up all those numbers right there, we got negative 4. But I want to find the average. What do I have to do to find the average or the mean? Angeline?
Divide it.
Excellent. We're going to divide it by the number of numbers in our data set. How many numbers were there in the data set, including the 0? Because somebody voted for that 0. There's 8 of them. So I have to divide it by 8. Can negative 4/8 be reduced to what?
To 1.5. Negative 1.5.
Negative 1/2. Now, my question goes back to the original problem. Should the restaurant consider changing their recipe?
Yes.
Yes, they should. And now it says to explain. Raise your hand if you could explain to me why you think they should change their recipe. Okay, so their score averaged out was below 0. If somebody rated some kind of recipe below 0, I don't think I would want to go to that store. The homework for 2.5 is on page 77. How many problems are there?
9.
There are 9 problems. Now here's the deal. This is not due until Friday, but you are allowed to start it tonight and get finished with it earlier. Okay, so this is the homework for 2.5.